Good evening, students.
Good evening, sir.
Good evening, beta. So, so today I am going to, in the last class, I have discussed center of mass, and after that, today I am going to discuss torque. Okay, torque, and but before that, I want to give you some the position of the center of mass for some standard bodies. So, before this center of mass of some standard bodies. For example, if you are having a road, ठीक है, if you are having a road of length L, ठीक है, this is a road, uniform road of length L, ठीक है, this road is uniform road, then its center of mass will be at the center of it, ठीक है. So where will be its center of mass? Exactly at the center of it. So first body is, ठीक है, this road. second is second is half ring. Second is half ring. You have to remember this ring. So if you are having a ring like this, half ring, this will be very helpful if you remember these formulas. This will be very helpful. So if it is 0, 0 here, this is origin O, O, and this is y-axis, this is x-axis. Then center of mass will be here. This will be, this will be a 0. X coordinate of the center of mass will be here at 0, and this will be 2r upon pi. This will be 2r upon pi. So for a half ring, ठीक है, of radius r, here what is the radius? Radius is r. This will be the position of center of mass, you have to remember. ठीक है. Then this will be half disk. Then this will be a half disk here. Half disk. So if you are having a half disk like this, and here we assume that this is the origin. So this will be y-axis and this will be x-axis. Here this will be plus r, this will be minus r. Okay. So radius of this half disk is capital R, is capital R. So where will be its center of mass from here? Basically, try to understand about this x-axis on both sides of this y-axis, not x, y-axis. On both sides of y-axis, mass distribution is symmetrical. Mass distribution is symmetrical. So x coordinate of the center of mass will be 0. ठीक है, that will lie on the y-axis. And what will be the position of the center of mass? This will be center of mass C. X coordinate will be 0. And this will be 4r upon 3 pi. So in case of half disk, this will be 0 and 4r upon 3 pi. 4r upon 3 pi. ठीक है, this is. Please note it down. This will be very helpful in solving questions. Next is half sphere, hollow hemisphere. You can say. Next is hollow hemisphere. Number 4. Hollow hollow hemisphere. This will be so. here it will be like this. This will be x-axis, this will be y-axis, and this will be z-axis. Okay, z-axis. So here this radius is r, radius of this hemisphere is r. So center of mass will be here. What will be its coordinate? 0, 0, and r by 2. Okay, so this will be the position of center of mass in case of hollow hemisphere. In case of hollow hemisphere, this will be. Next, if you are having a solid hemisphere, solid hemisphere, hemisphere, this will be. This will be. So what will be? This is origin here and center of mass. Okay, center of mass will be here. Okay, so in case of solid hemisphere, this will be how much? This will be uh 0, 0, and it should be 3r upon it. 3r upon it. So this will be the center of mass in case of solid hemisphere. Okay, so in case of hollow hemisphere, it will be at r by 2. In case of solid hemisphere, this will be at 3r by 8. It will be at 3r by 8. Next, it will be a cone. Okay, so please note it down quickly. Next is hollow cone. Next is hollow cone. Hollow cone. So if you are having a hollow cone like this, height of this hollow cone is suppose h. So here this will be x, this will be y, and this will be z. So if height of this is h, then it will be, I think, at h by 3. Okay, it should be 0, 0, and h by 3. Okay, 0, 0, and h by 3. It will be in case of hollow sphere. In case of hollow sphere, this will be at 0, 0, h by 3. This will be the center of mass. If you are having a solid cone, okay, if you are having a solid cone, this will be x, this will be y, 0, and this will be z. Okay, so this is the origin. It will be at h by 4. So 0, 0, h by 4. This will be the center of mass. So these are some very important objects for which center of mass you should be aware of. Okay, you should be aware of about the center of mass of these bodies. So when I will discuss the questions related to center of mass, that will be very, very helpful. Okay, that will be very, very helpful. You have to remember all this. Okay, you are going to remember all this. Next, next is torque. Okay, next is torque. Here, in case of rotational dynamics, three important aspect is there, three or you can say four. First is center of mass, you should understand, ठीक है, how to find out the center of mass. Second, you should know how to calculate torque. Next is how to find out angular momentum. And then next is moment of inertia. Moment of inertia I have already discussed. You can go through videos, ठीक है ना, of center of mass. And even I have calculated moment of inertia tensor also, and that type of calculation I have already done. So basically next is here torque. So first I have discussed center of mass, then second will be torque. Torque. ठीक है. So what is the meaning of torque? Suppose you are going to have a this type of wheel. ठीक है. This type of wheel is there and it is pivoted about this axis. So basically this is pivoted about this axis. This is the axis about which this wheel can rotate. ठीक है. So you are going to have this type of wheel. And if you apply a force over it, ठीक है, if you apply a force over it here, if you apply a force like this F, then by applying this force, this wheel which is pivoted on this axis, it is going to rotate. It will rotate beta. So by applying a force, ठीक है ना, this wheel is going to rotate. So we are going to say that a torque is acting on it. What we are going to say, a torque is going to act on it. So torque is equivalent to the force. ठीक है. Force in translational motion, ठीक है ना, force is the region due to which translational motion is taking place, and equivalent of this in rotational motion is torque. So due to the torque a body is going to rotate, so the rotation of the body is caused by a torque. ठीक है. So here when this body is pivoted like this and you are applying a force in this way, then this body is going to rotate. So we are going to say that a torque is acting on it. So what we say a torque is acting on it. So it is going to rotate about this point O, and here this will be the R axis. ठीक है ना, this will be R vector here. ठीक है, R vector in this way, and this is F. This is F. So basically torque, how much torque is acting on it? Torque that is acting on it, it is given by R cross F. ठीक है. Torque is given by R cross F. So R is the position vector of the point at which you are applying the force. You are applying the force at this point P. So what is R? R is the position vector of this point with respect to the axis about which you are going to rotate it. So what will be the torque in this case? Torque will be equal to R cross F. Now second, if you are having a hinged body like this, suppose you are having a hinged body like doors or something. For example, suppose you are having a hinged body like this. ठीक है. So about which your door is going to rotate. ठीक है ना. So door is going to rotate about this. So door will be something like this. So this type of door, this is called as hinged body. This is pivoted body. Pivoted body. This is called as hinged body. Hinged body. So if you apply a force over it like this, ठीक है, so we have applied a force over it like this, then this will be the F and this will be R. This is going to be R. ठीक है. So what will be the torque here? Torque here again it will be R cross F. So this will be torque. Torque will be R cross F. In which direction it is going to rotate? try to understand, this is first vector, this is second vector. What you have to do, you have place your palm in the direction of first vector and rotate your palm, your fingers in the direction of second vector. So what you have to do in case of cross product, you have to point out your fingers, ठीक है, your palm in the direction of the first vector, and then rotate your fingers, ठीक है, in the direction of the second vector. So here in this case, this is R. So this is R vector here, and you are going to rotate it. You are going to rotate it. So in which direction it is going to rotate? So rotation will be like this. ठीक है, rotation will be like this, and torque will be inward. If you look at this, then torque will be in this direction. So it is rotating like this. So you can say that torque will be in this direction. This will be the direction of the torque. Okay, this will be the direction. So in this way, this will be the direction of the torque. So try to understand here. Okay? So here this will be R vector, R cross F. So from here to here, or you can say this is going to rotate like this. This will be the direction of the rotation from R cross F. So what you have to do, simply you have to draw a vector like this from the first vector R. This is R vector towards F vector. So this will be the direction of rotation. So in this way it is going to rotate. So this is hinged body. What is this? This is hinged body. Third is suspended body. Third may be suspended body like this. So it may be suspended body like this. ठीक है ना, this will be, and it is going to rotate. ठीक है, where its weight is going to act, ठीक है, it will be like this. ठीक है ना, its weight is acting in the downward direction. ठीक है, so if you apply a force over it, ठीक है ना, try to understand, if you are applying, weight is acting here, over here, but that is passing through it, so R cross F will be 0 for it. ठीक है, its center of mass is here, weight is acting like this. So what will be the R vector for the weight? Will be here, this will be R. So R and mg, they are in the same direction. So cross product of R and F, that will be 0, sine 0 will be there. So here, if you apply a force over it in this direction or something like this, then this will be the R vector here in this case. So if you are applying a force like this, then this will be the R vector. This will be the direction of R vector. So in this way, it is going to rotate. So whenever you are applying a force on the pivoted body, hinged body, or suspended body, then they try to rotate. And we say that a torque is acting on it. And we say that a torque is acting on it. So you can write the definition of the torque. Please write the definition of the torque. So here three type of bodies may be there. One is suspended body, hinged body, or pivoted body. First, write the definition of the torque. If a pivoted, hinged, please write, if a pivoted, hinged, or suspended body, if a pivoted, hinged, or suspended body is acted upon by a force, is acted upon by a force, and it tends to rotate, and it tends to rotate, and it means body, it tends to rotate, then it is said that torque is acting on it. Then it is said that torque is acting on it. Then it is said that torque is acting on it. Torque is acting on it. Here I assume O point, this one. This is the O point. ठीक है? ठीक है. So this will be. Is it clear to everyone?
Yes, sir.
Now, next is torque is also known as moment of the force. Torque is also known as, just 1 second, is also known as moment of the force. Moment of the force. Okay, why you are saying like this? Suppose this is the origin here. ठीक है, a body is moving. ठीक है, this is the body and a force is acting on it like this. This is the line of force. So what I'm saying, a force is acting on it like this. This is F. ठीक है, so a force is acting on it. Now what, where the force is acting? Force is acting in here. So this will be, so here at this point force is acting like this, and this will be the r vector, and this is r vector like this. So what is going to happen? ठीक है, this force is going to rotate it in this direction. ठीक है ना? So it is going to rotate it in this direction. So this force will try, when you are applying, then it will cause a rotational effect, and that rotational effect will be around this in this direction. So that will be. So if on an object force is acting, then this applied force due to the torque about this point O, it will try to rotate in this direction. In this direction. Now, what do you do? Draw a perpendicular from here. Suppose this is theta. So what will be the torque here if you write? That will be R cross F. R cross F. So what is torque? That will be RF sine theta. So this will be F and this will be R sine theta. This will be F into R sine theta. This is theta. So this angle will also be theta. What do you do? Draw a perpendicular from here. This perpendicular is represented by P. And if you want to represent this as a vector, then this will be P vector. I can say this is, and mode of this, length of this vector will be P. And what will the length of this? If you look at this is P vector here, P vector here. What will be this P? This is R. What is the length here? That will be R. So length of this is R. This angle is theta. So this P will be R sine theta. So what it will be? This will be R sine theta. So mode of P will be R sine theta. So what can I write here? That this will be F into P. So what is torque? Torque is F into P. Now this P, if I am writing the formula of the torque in the vector form, then this formula should have the same rotational effect. So if you are taking the definition R cross F, then rotation is taking in this direction. So if you are converting this formula in terms of F and P, then rotational effect should remain same. So it should be from direction of rotation should be the same. So it should be from P to F. So what can I do here? I can write P cross F. P cross F, this will be torque. This will be the torque. So P cross F, it is going to have same rotational effect. And what will be the angle between P and F? This is F, this is P, and angle between them is 90 degree. So sine 90 is 1. And what this is called as moment of force. This is called as moment of force. Moment of force. So basically, you can also use this formula to find out the torque. ठीक है, you can always use this formula to find out the torque. So what you have to do, the point about which rotation will take place, from that point you have to draw a perpendicular on the line of action of the force. So what is this line? This is the line of force. So this line is line of force. ठीक है, this is line of force. Line of force. So what you have to do, you have to draw a perpendicular from the point about which rotation will take place, and you have to draw this P. ठीक है, perpendicular over it, and simply F into P will be the moment. This will be the magnitude of the torque. ठीक है, this will be the magnitude of the torque, and you are going to use this definition frequently when you are solving questions of rotational dynamics. When you are going to solve the questions of rotational dynamics, this definition will be the most beneficial. ठीक है, so you have the point about which rotation will take place. ठीक है, from that point you have to draw a perpendicular on the line of force, and just multiply that length of the perpendicular with the force. That will give you the torque, magnitude of the torque, and direction. In this way, by drawing a vector like this, curved vector from the first vector, from this first vector to second vector, from this first vector to second vector, you can draw a vector like this, and you can find out the direction in which expected rotational motion will take place. ठीक है, in which expected rotational motion is going to take place. ठीक है, this is. Now please note it down quickly. Next. ठीक है, here if you are considering rotational motion, in rotational motion, torque, it is going to do the same job as force does in translational motion. Translational motion. So whatever is the objective, so whatever is the role F is playing in translational motion, same type of role is played by the torque in rotational motion. Here force is responsible for translational motion. Here torque is responsible for the rotational motion. What will be the torque? Torque will be rate of change of angular momentum dl by dt, where force was equal to rate of change of linear momentum dp by dt. ठीक है, dp by dt. What was P? P was mass into mv, P equal to mv. What is here? This L. ठीक है, L कितना होता है? ठीक है, that will be, if I remove this, that will be I omega. L equal to here I omega. So here correspondence of the mass is I, moment of inertia. So whatever role is played by the mass, ठीक है, this is the mass. Whatever role is played by the mass, here same role is played by this moment of inertia. By this moment of inertia. Inertia. That will be equal to L equal to I omega, and that will be, ठीक है ना, that will be P equal to mv. P equal to mv. Now what is the force? Another form of the force, that is mass into acceleration in the translational motion. So if you are applying a force, that will consequence into an acceleration. So here if you are applying a torque, then it will be equal to I alpha. I alpha. So alpha is here angular acceleration. Angular acceleration. Angular acceleration. Alpha is known as angular acceleration beta. ठीक है, Now here power, if you look at power, it will be F dot V, F dot V. ठीक है. Power in case of translational motion, it can be written as F dot V. Here, power in case of rotational motion, F will be replaced by torque dot V will be replaced by omega vector. This will be, ठीक है. This will be. Here, work done, that will be integration of F dot ds. Work done, formula is this. Here in case of rotational motion, work done will be integration of torque into d theta. ठीक है ना, t torque into d theta. So this is the comparison between translational motion and rotational motion. So one-to-one correspondence is here. So in this way, you can observe that the counterpart of the mass here in rotational motion is I. Corresponding to A, you are having alpha. Corresponding to F, you are having a torque here. Corresponding to P, you are having L here. So in this way, one-to-one correspondence is there in case of translational motion and in translational motion and in rotational motion. Rotational motion. Next is beam balance, beta. Next is beam balance. Beam balance. ठीक है. So if you are having a beam like this is a beam and it is pivoted. This is a beam here and it is pivoted here, suppose. So this beam is pivoted like this here. ठीक है. It will be so. Just so beam is pivoted like this. It is. Now, if you apply a force or you can say weight, if you place a weight here and this weight, it's the weight mg, it is going to act in the downward direction. I call it as F1. ठीक है. So F1 is the weight that is acting in the downward direction. And here you place another weight. ठीक है. And suppose due to this, its weight F2 is acting in the downward direction. ठीक है. You place another weight here and this will be suppose F3. So F1 can be M1G, F2 can be M2G, F3 can be M3G, and they are all acting in the downward direction. So this beam will be balanced. ठीक है ना? This beam will be balanced if net torque acting on it is zero. If net torque acting on it is zero. So can you tell me one more thing? Suppose here, try to understand. Try to understand here. This is the point where this force is acting. Force is acting at this point. This is F and this is R vector. R vector. So it will be like this. So here it is going to rotate. So basically this force will try to rotate in this direction about this point. So rotation will be like this. So try to understand what will be the direction of this torque. Torque will be along the axis of rotation. ठीक है. So torque is always acting along the axis of rotation. ठीक है. In the upward direction, if you can write like this, thumb in the outward direction. ठीक है. Torque is going to always act in the outward direction. That's why this torque always, you can observe, torque always acts along the axis of rotation. Axis of rotation. try to understand this torque is always going to act along the axis of rotation. That's why this torque, due to this region, this torque is called as axial vector. ठीक है? Due to this region, it is called as axial vector. Torque is axial vector. So try to understand these axial vector comes into the picture when you are dealing with the rotational motion. So these axial vectors, they come into the picture when we are dealing the rotational motion. So in vectors, you have studied one type of vector is axial vector that always acts along the axis of rotation. So one such vector is torque. So torque is an example of axial vector. Another important thing is, okay, before discussing this, because I'm going to use that point here. If, okay, please write a note here. If torque, torque, try to rotate the body, in anti-clockwise direction, in anti-clockwise, direction, then torque is considered as positive. Then torque is considered positive. Then you are going to consider the torque as positive. Okay? Then you will consider the torque as positive. Okay? If, number 2, second point, if torque tries to rotate the body in clockwise direction, then torque is considered as negative. Torque is considered negative. So basically, in this way, we decide the positive and negative sign of the torque. So if a torque is acting on a body and it tries to rotate the body in the anti-clockwise direction, then you will consider that torque as positive. If torque tries to rotate the body in clockwise direction, then you are going to consider that torque as negative. Okay. So here, look here. If you are saying this beam is balanced, okay. So if beam is balanced, means it is horizontal, then net torque acting on it, it will be 0. Then not net torque acting on it will be 0. I assume that this is x1, this distance is x1, this distance is x2, x3, sorry, and I say this distance is x2. So try to understand what will be the r vector here. So from here, this is the point about which this beam is going to rotate. So basically here, draw a perpendicular. This is my line of force. And you are going to draw a perpendicular from here to here. So this is P vector. This is P vector here. If you look at, then this P cross F, that will be the torque. In which direction it will try to rotate? This F1 will try to rotate this beam in this direction. This is anti-clockwise. So I'm going to consider it as positive. So because it tries to rotate this beam in anti-clockwise direction, so I will consider this as positive. So I will write this is x1 perpendicular distance, F1. This is the torque. ठीक है, that is created by this F1. Now consider this F2. So you are going to draw a perpendicular from here on the line of action of the force. This is the line of action of F2 force. So this is x2. What is this? This is x2. And what will be the direction of rotation it is going to cause? So this is the first vector P2 and this will be F. This is clockwise direction. So this distance is x2 and F2 and this will be negative. This will be x2 F2 F2 x2 F2. Now consider this F3. Its line of action is this. So you will draw a perpendicular like this. So this will be P vector and this is x3 and this is F3. So again it is going to rotate. This force is going to rotate like this in clockwise direction. So it will be negative minus x3 F3 and that will be 0. That is going to be 0. So net torque acting on this beam is 0. Beam balance. So what it will be, you take these two terms on the right side. So this will be x1, x1. It will be x2, f2 plus x3, f3. x1, f1 equal to x2, f2 plus x3, f3. So in this way, you can create a equation and you can solve the questions of beam balance. So if you want to make this beam balanced, then net torque acting on it should be 0. So this type of question may also be there where this type of concepts are used. Okay, is it clear to everyone?
Yes, sir.
Good. Now, example 1 here. This is example 1. You are having a cubical body here. This is a cubical body. ठीक है, side of it is A. ठीक है, this is a cubical body that is placed on the earth like this. ठीक है, you apply a force. Side of it is A and you apply a force F here. F here. And what is the distance? This is the center. This will be the face and just above it. Try to understand where you are applying the force. This is the face here. This is the center above it. Okay? It is like this. If you are looking this side will be something like this. So where you are applying the force, it will be. So I can just show you how it will be. This type of cubical body is there. This is the center and here this is the center of this face and above this a force F is applied. ठीक है? At what distance? At what height you are going to apply the force? That is 3a by 4. What is this? This is 3a by 4. 3a by 4. This will be 3a by 4. So you are applying a force on it and you want to rotate this. By applying this force, you want to rotate this cube like this about this edge. This is the edge about which you want to rotate this. I want to rotate this in this way. ठीक है ना? So find the minimum force. Please write here. Please write here. Find the minimum value of force for which. Find the minimum value of force. Find the minimum value of the force F for which. For which. Find the minimum value of the torque for which this cube begins to tip, for which this cube will begin to tip about this edge, AB, about this edge AB. ठीक है? About this edge AB. So you have to find out this. Now, you are going to tell me how to solve this question. Okay. So its center will be somewhere here. Its center will be here. So in both diagrams, so its weight is going to act in the downward direction. It will be mg. mg. ठीक है. You want to take a rotation about this, so draw a perpendicular from here to here. From here to here, that will be a by 2. a by 2. ठीक है. Second is this force, and this force is at a distance, perpendicular distance is 3a by 4. 3a by 4. So from here, this will be the p vector. ठीक है. What you have done, this is the position from which rotation will take place. So from this point O, I draw a perpendicular on the line of force. This is the line of force. So this is length of this is 3a by 4. So this p, you can say this p will be in this direction, and it is going to rotate this cube in this direction. And if you draw a perpendicular from point O on this another way, force, that is weight here, then it will be like this. This will be P2. P2. So it is going to rotate like this. So basically this mg, whatever torque is created by this mg, that is opposing the rotation. Who is responsible for rotation? For toppling, or ठीक है, for rotation of this cube about this edge, this force. ठीक है ना, the torque that will be created by this force, that is responsible. ठीक है ना, that torque is responsible. So torque that is created by this F should be greater than the torque that is created by this weight mg. So F and perpendicular distance from point O on the F, that is 3a by 4. So F into 3a by 4. F into 3a by 4. This should be greater than this, the torque created by mg, and that is a by 2. That is a by 2. So F should be greater than, this will be, a will cancel out from both sides. So this will be 2 mg upon 3. So this should be the minimum force. 2 mg by 3 is the minimum force. ठीक है ना? This is the limit. So the force should be greater than, this is the limiting case. At this force, this cube will be ready to rotate. But if a force is a little bit greater than this, then automatically this cube will start rotating, or it is tipping about this as AB. So this is example 1.
सर,
This is example. Yes, beta, please.
आपने ये P2 वेक्टर उस डायरेक्शन में कैसे लिया, एक बार बता देंगे प्लीज?
Yes, beta. So here, you look here. This is the edge. ठीक है ना? Try to understand, this is the edge. ठीक है ना? So this is the edge about which rotation is going to take place. And what is the line of force? Line of force is this. So I will draw a perpendicular from here to here. So this is actually P2 vector. So I expanded this so that I can draw the direction of rotation. So this is P2
यस
vector.
सर, अंडरस्टूड.
And now from here, I will draw a perpendicular on this force. So this will be the direction of P1. ठीक है, I further extended it so that I can draw the rotating direction. So in this way, you can solve this type of question. So this is a very famous question. Next, one more question that is very good. So try to understand. First, draw this is first example. Next, example 2. Example 2. So if you are having a sphere like this of radius r, ठीक है, this is a sphere of radius r. Here, this is horizontal surface, and it is like this. So this is horizontal surface. ठीक है ना, it will be like this. So here it is center, center is here of this sphere, ठीक है, and you are applying a force in this direction. Why you are applying this force F? ठीक है, this is an obstacle. What you want to this? You want to move this sphere. You want that this sphere should overcome this obstacle and it will start rotating about this point. This is the point of rotation here. It should rotate about this so that it can overcome this obstacle and it will start rotating here, rolling here in this direction. It is like this. So radius of this is r. So you can say this radius is r and this height from here to here, this height is h. So this height is h from here to here. This height is h. So this distance, this will be r minus h. Now please write the question. A wheel of or a sphere लिखो. A sphere of radius r. Sphere of radius r and weight w is to be raised. A sphere of radius r and weight w is to be raised over an obstacle of height h. Over an obstacle of height h. Over an obstacle of height h by a horizontal force F. By a horizontal force F as shown in the figure. As shown in the figure. As shown in the figure. Find the minimum value of F. Find the minimum value of F. Okay, you have to find out the mini. So what is the point of rotation? So try to understand first this point P. This point P is the point of rotation. So two forces are acting. One at the center of it, this is center of mass. So weight is acting downward. You know, mg that is acting here. So weight is acting at this point. Second is this force. So what I do, this is the point of rotation. I will draw a perpendicular from here to here. This will be P1. What you are going to call it, this is P1. I draw it further because this will give me the direction of rotation. So this is P1. So it will try to rotate this sphere in this direction. So basically this torque that is created by mg, that is opposing the motion of this sphere over this obstacle. It want to move up, but it is opposing. This is the opposing one. Opposing one. So what is the torque? This distance, what it will be? So try to understand. This is r. This is r. Okay. You want to find out this distance. And what it will be? This is h. So this will be r minus h. ठीक है ना, so this will be r minus h here. So this will be r minus h. ठीक है, so what it will be? Try to understand. This will be r minus h. And this is r. So what will be this distance? P1. This P1 will be r square minus r minus h square and square root of that. So mg, torque created by mg will be mg multiplied by this square root of r square minus r minus h whole square. R minus h whole square. This will be. Next will be this force. This force F is there. Draw a perpendicular from here to here. ठीक है ना? So this will be P1 or you can say P2. So this will be P2. In which direction it will rotate? It will rotate it in this direction. This is P2. So it will rotate this sphere in this direction. ठीक है? And what will be the torque here that is created by F? That will be F into this distance. This distance is r minus h. So torque that is created by this, that will be F into r minus h for rotation of this sphere so that it can overcome this torque should be greater than this one. So it should be like this. So what will be the minimum force? Minimum force is given by this. This will be mg square root of r square minus r minus h square divided by r minus h. R minus h. So this will be the minimum force. This is the minimum value of the force at which this sphere will be ready to overcome this obstacle. If force becomes a little bit greater than this, then it is going to move over this obstacle. It will move over this obstacle. Is it clear, beta? This will be the answer. So here, this will be our answer. So this question was there in the exam. Okay. 1 year back or something. But it was in the, they have given numbers, they have given capital R, small h, everything they have given. So today I am going to stop here. In the next class, I will discuss first angular momentum, and then I will discuss numericals. ठीक है, numericals of torque, numericals of center of mass, torque, and angular momentum. So first, I have completed these two. In the next class, I will discuss this angular momentum, and then I will discuss their numericals. ठीक है, ठीक है बेटा. So now you can have the pics. You can save these
Sir,
slides. Yes,
sir,
beta. Yes, beta,
about
please.
that last example,
Okay, बेटा बताइए please.
ये राइट हैंड साइड में एम जी मल्टीप्लाइड बाई वो ये पार्ट एक बार बता दीजिए ना वापस.
Okay, beta.
राइट हैंड साइड
Yes,
वाला.
yes, beta. So here, this is, I want to find out this length. ठीक है, because this is my line of force. This is the line of force. I draw a perpendicular. This is the rotating point. So I draw a perpendicular. I want this length. And to look at this triangle. This is R. Hypotenuse is R. Perpendicular is R minus H. So what it will be? This will be using Pythagoras theorem. This will be R square. Hypotenuse square minus perpendicular square. So R minus H square. So this length will be this one. Is it okay or no?
That means we don't need that whole length, like the whole
No, no,
from.
we just need the length of the perpendicular that we are drawing from the point of rotation on the line of action of the force. ठीक है, on the line. So this is my force. This is the line of force. This is rotating point. So I will draw a perpendicular from here to here. So I will draw perpendicular from here to here. I need this length. ये लेंथ चाहिए मुझे. ठीक है.
Okay.
So I, ठीक है, here this is my line of force. Try to understand. So from here I will draw this. I need this length. This length is r minus h. This length is this one. Is it okay now?
Yes, sir. Thank you, sir.
Welcome. So kindly save these slides if you want. I'm showing you all the slides here. Number one, second one, third, fourth, fifth, sixth, seventh, eighth, nine. So these are all the slides. Thank you, beta. Good night.
Thank you, sir.
Thank you, sir.
Welcome, beta. Welcome, beta.